Okay, so have you ever had a teacher give you a formula and they just pretty much say, here it is, use it, right? And you don't really even know what you're doing and why you're doing it. The difference quotient is actually very important, very. If any of you are going to continue on to higher level math, you will see this again. But you've seen it already, and you're going, nuh-uh, I haven't seen anything like that, What if I started out with that formula? What is that formula? It's the slope, I hear you screaming, Cindy, it's the slope. What if now I wrote the same formula, but instead of y's, I made it a function of x's? So that's the f of x2 and x1, and then the same thing here at the bottom. All right, still doesn't look familiar. Well, let's say I want to call that piece h. All right, so you can kind of already see the h at the bottom. And I know you're like, why do you want to call it h? You'll see. If I call this h, so h equals x2 minus x1, notice I could solve this for x2. So I can move the x1 to the other side, and I get x2. So if you're kind of playing along of what I'm doing here, what I've done now is I've made this formula for the slope with only one value of x, and hence what you see over here. Pretty exciting, huh? So, sometimes it's kind of cool to see how this stuff originates. And so now you're going to learn to use this difference quotient. So let's say that they give you f of x equals negative 3x plus 10, and to plug it into the difference quotient. So the difference quotient says where you see, let's undo that. I'm going to go ahead and start writing it. Where you see an x in the formula, put x plus h. All right, so that's this piece. Now it says where you see an x in the formula, just leave it as an x. And then all over h. I tend to write it out to the side so I don't waste a lot of space. From here now, I can go through and first distribute. So I'm going to have negative 3x minus 3h plus 10. Might as well go ahead and distribute this negative here. So a negative and a negative is plus 3x, and then minus 10 all over h. What is cool that will always happen if your algebra is correct, anything that does not have an h will cancel. If it does not, then you just made a tiny mistake with your algebra. And so I'm left with this negative 3h, that piece right there, divided by this h. As you hopefully can see, the h's cancel, and I get an answer of negative 3. Do you know what that negative 3 is? It's the slope. And so this difference quotient, it's easy to understand with a linear. It's just the slope. So you're just finding the slope. Might not make quite as much sense. Let's do a more complicated one. But again, this is something that comes up later, is I want to use the difference quotient. So where I see x, I plug in x plus h. And then where I see x, and you notice me using these square brackets. I do this because I want to make sure that I am distributing that negative sign. And hopefully you kind of sort of remember that this is FOIL. So that means x plus h times x plus h, which is x squared plus xh plus xh plus h squared, which gives me the 2xh plus h squared. All right, so that's that piece. So I get x squared plus 2xh plus h squared. Don't forget that minus 2. I'm going to go ahead and distribute now my negative. So that'll be minus x squared plus 2. And you remember what I told you. If it does not have an h, trust me, it will cancel. If it does not cancel, then you just need to check your math. Check your algebra. All right, so I have 2xh plus h squared all over h. Up top, both of these have a common factor of h that I could factor out. Right, so notice if you distribute it back, you would see that you'd get the 2xh and the h squared. I can now cancel the h, and I get my final answer of 2x plus h. Again, the difference quotient, I think, makes a lot of sense with a linear, that it is a slope. If you go further on in higher up math courses, you're going to see it has the same meaning with something of this sort. But that is the difference quotient.